Greetings to everyone watching this video. I am Pragati Yadav and today I will be explaining about the Stern-Gerlach experiment as a part of my quantum computing teacher's assessment. I will be explaining about the Stern-Gerlach experiment. First, I will give a basic introduction of the topic, which will be followed by the description of the apparatus used in this experiment, and then a detailed information about the procedure, and then the observations and the conclusion of this experiment. So, the Stern-Gerlach experiment plays a very important role in quantum physics and quantum mechanics and quantum computing as well. In this experiment, we study the behavior of atomic particles when it passes through a non-uniform magnetic field and see if it behaves according to the rules of classical physics or as per the rules of quantum mechanics. So this experiment was performed by physicist Otto Stern and Walter Gerlach in the year 1922. The objective of this experiment was to see or to investigate the angular momentum of the atom, specifically the magnetic moment associated with the atoms or specifically the electrons, and see their behavior and to see if it valued or it followed the laws of the classical physics or the laws of the quantum theory. The experiment wanted to determine whether the projection of the angular momentum along with the external magnetic field axis or the Z component faced any kind of deflection or quantized outcomes. Ultimately, the goal was to test the quantum hypothesis of angular momentum quantization and examine the fundamental structure of the atomic magnetic moment. So now we will see the apparatus required for this experiment. First, we have an oven. Oven is similar to a furnace and it contains a metal inside. In this particular case, it has silver metal inside it. Then the next part of the apparatus is a collimating slits. Slits, the beam of the electrons or the beam of the atom will pass through these slits. And the next part of the apparatus is the magnets and then the screen which will finally see and observe and record the observations of this experiment. Now we will see in a detailed way the role of each and every item in this apparatus. This is also the diagram of the Stern-Gerlach experiment. It is different from the setup. It can be made easily. This also explains the same situation, that is the oven, the slits, the varying or the non-homogeneous magnetic field, and how the atom faces or the electrons face the deflection and give two different outputs in this situation. So very first, the silver atom oven. It is similar to a furnace and it has silver atom inside it and which is heated to an extent when it becomes in a vaporized manner. When it is vaporized, it is passed from the oven in a form of continuous and steady atomic beam. When it passes from the oven in form of the steady atomic beam, it passes through the collimating slits. Because of the help of these collimating slits, it gets a defined shape and it gets a defined shape and is continuous in its manner and is not broken in any part, and that's why it passes through properly through the magnetic field. Next part is that the beam passes through the non-uniform magnetic field. This non-uniform magnetic field is produced by the non-uniform or the specially shaped magnets, which is one sharp and the other is edged to the bottom. Now we will see the procedure of this Stern-Gerlach experiment and understand how and what exactly happened. So the very first thing was inside the oven, the silver atoms were heated. They were heated until they were present in the form of atomic vapors. And when they finally vaporized, these vaporized atoms escaped the oven through a small opening. This creates a narrow beam of the moving atoms. Then these moving atoms passed through the collimating slits, and when they passed through these slits, they aligned the atom into a straight, thin, and a controlled beam. Collimation ensures precise measurement of the deflection of the atoms. The collimated beam enters the region with a strong magnetic field, and in this magnetic field it faces some kind of deflection, and whatever is the result is then later seen on the screen. So in this case, the splitting of beam is observed. Instead of spreading continuously, the beam splits into two distinct paths, and we can call this as the upspin and the downspin as plus 1 by half and minus 1 by half. And this result is observed on the screen or the plate. Two separate spots appear that prove that the atom has a quantized spin magnet moment. Now we will discuss the final observation through this experiment and understand what actual inference or conclusion can be drawn out from this experiment. So in this Stern-Gerlach experiment, the most significant observation that was made was that the collimated beam of the neutral silver atoms did not form a continuous band as it was expected by the classical physics rules. Instead, the beam split into two separate spots, showing that the atoms were deflected in only two distinct directions. This discrete splitting indicated that the magnetic moment of the silver atoms, and therefore the spin of their unpaired electron, can take only two distinct quantized values. The absence of any atom between the two spots confirmed that there are no intermediate or continuous, rather, or different observations. Only two quantized spin moments exist, that is the plus 1 by half or the minus 1 by half. This can be seen two distinct, which is minus 1 by half and plus 1 by half, can be observed in this case. This image is an actual image of the experiment, and we can see how it goes here like this. Now, the point that I want to say is why is specifically silver atom used in this experiment? Was any other atom? Why isn't any other atom except silver used in this? So silver has a single unpaired electron. Silver has the electronic configuration of krypton 4d10 5s1. So the one unpaired 5s electron gives it a simple, well-defined magnetic moment. Besides that, the silver atom is electrically neutral and behaves similar to any noble gas configuration. That's why also it is very stable and non-reactive. So silver does not easily react with any other apparatus materials, and it ensures that the result of the experiment is not hindered by any other element. Besides that, the atom is electrically neutral, so which again proves the point that it will only be affected by the magnetic field and not by any other element besides that. So with this, we conclude this experiment. So the beam of silver atom splits into two discrete components when it is passed through a non-uniform magnetic field. This provides the evidence for the quantization of angular momentum and the existence of the spin moment of the electron. This result runs or is against the classical expectations of physics, as the magnetic orientations reveal that the atomic scale system possesses only specific allowed quantum states. The experiment not only confirmed one of the earliest predictions of quantum theory, but also laid the foundation for the modern developments of the atomic physics. So, with this, I conclude my topic. Thank you very much for watching this.